ocean, I'd say 20%.
Because we use some of it.
We use some of the energy.
Mm-hmm. We consume a lot, right?
But the thing about energy is it never really goes away. You can't really use it up.
It would have to break even, wouldn't it? Same amount, yeah.
You know, cause and effect, it'd be equal in some ways, right?
For most of the Earth's history, it should be exactly the same amount of energy in from the sun as Earth radiates into space.
What kind of stupid logic is that? Oh my god, Derek! Derek! You can't lie like this! It doesn't work that way. First of all, the sun can only put out so much, and guess what sunglasses do? They make the amount of energy from that light be a lot less so that it doesn't hurt your eyes as much. Guess what the ocean does? The entire ocean absorbs a lot of the light. So what do you end up with? A moderately warm Earth. Also, there's the fact that space is affecting the atmosphere. And that changes stuff about how the Earth also is warm or cold. So, if you were to have a tidally locked Earth, you would have a completely different amount of energy absorbed by the Earth. And let's, for some reason, be able to say that we have some kind of amazing amount of ocean on the one side of the Earth that's facing the sun. Or we also have some kind of other sunblock system. For example, even if it's tidally locked, you have like an asteroid belt between it somehow that every so often will give it some shade. So what do we really get from the sun? It's a lot bigger question than whatever you're about to say, but I'm already only 1 minute into your video and I have a complete beef with you. Energy is always dissipating. Two objects collide with each other. You call that complete energy, like, done. Cancels out. Also, what do we get from the sun? We get momentum. The sun, apparently, is pulling us, and therefore we are able to have a lot of the energy that the Earth has going through everything else. But then the galaxy is pulling, so it's like, but it's not a regular pull, it's like some extra different kind of pull. What people don't understand about how it all works is that you literally are always losing energy over time. Everyone understands about the idea about heat death, that the sun's going to eventually go out and the black hole's eventually going to evaporate because of Hawking radiation, and the most amazing things in the world are just going to turn into, well, I mean, if it's a statue, it's going to live forever. Because unless something actually actively eats that statue, it's just going to be there. So heat death or not, you're still going to end up with mass, but all of the energy, all of the vivaciousness is apparently just going to be gone, and that's called heat death. We all understand that this is the natural function of how things are going to work. It's how thermodynamics and everything else predicts it. So when you say that energy is equal going from the Earth, if I were to give you an estimate as to how much energy goes from the Earth, first of all, the luminosity of the Earth is minimal. The radiation from the Earth is zero. Near freaking zero. We are not a star. The star is so amazingly powerful, it's able to give us, besides the light, it gives us the energy with the plants and everything and all of that. It gives us the heat by constantly warming up and bumping up all of those light, bumping against our soil and our atmosphere, heating it up, and allowing us to have the warmth that we lovely share and enjoy. So, what happens with all heat? Well, heat naturally, according to entropy, constantly wants to dissipate. If you leave something warm somewhere, something like extra hot, like whatever you had on your pot in the kettle, unless you're adding more heat into it, it's just going to turn into room temperature and spoil. If you add something that's extra cold, it's going to turn into room temperature. It's going to turn into water again instead of being ice. So unless you're putting energy into something, it's always turning into that more neutral state. And eventually, that's why we believe eventually we go to heat death. So energy is constantly being destroyed all the time, eliminated, canceling out, turned into less. The entire universe on a whole is basically losing a galaxy of energy per second or something insane. Or per nanosecond, for all I care. The galaxy is so huge and the amount of energy loss is so great that we are losing galaxies every nanosecond. Is a tiny estimate compared to what's actually happening. So, when you say that energy is the same throughout, Derek, I'm gonna slap you. You made a video about a car that moves faster than the wind because it's utilizing two different types of energy. The free energy from the wind, and the extra energy is from the momentum and friction against the ground, so that you have the wheels move, which turns the propeller, which makes it so it pulls the wind through itself instead of just going against the wind. It also attracts the wind, flows it through, and makes it so you have extra energy. And I predicted that the maximum amount of speed you get is not the same as the wind, but it's more than that. But you can't, my estimate is you can't go twice the speed as the wind with this setup. Because if the world is flat, whatever else, let's pretend that you're on a let's pretend you're on a salt flat, right? There's still curvature after a certain amount of kilometers. I'm going to say that. Moving on. Very much not, let's say not bumpy, not hillish. Okay, so otherwise flat along with the curvature of the earth and whatever. So you have it, it's completely smooth, and you go on the radius of the speed and everything. The most that you can get, based on the amount of, depending on the size of your wheels, right? Size of the wheel means you get more motion per moving forward. If you have a smaller wheel, then every inch you're having a rotation, right? If you have a bigger wheel, every foot you have a rotation. That's a translation of a factor of 12. And you go farther, every yard may have, if you have a yard size wheel. So that's 3 times as ineffective as your small wheel. So you need like a lot of grip, and you technically need a wide wheel, but you also want to be aerodynamic, so you probably have arrows in front of that so that it has some bit of things like a NASCAR, or no, like an IndyCar. They have those little things in front of the wheels. It protects. So you have the least amount of air, because you're constantly cutting into the air. It doesn't help you move forward. Your drag is like extra. So if you make a flat surface, then it's not cutting into the air and you have extra. Tiny fraction extra. The thing about entropy is that you can have machines that exert extra energy. So if I were to create a device as big as the galaxy, suddenly we have the ability to make more energy than we ever could use. Wait, we already have a galaxy. We're already using that momentum. We're already using that radiation. The most radiation we get is from the sun, because everything else is dissipated so much that it's just a tiny speck in the night sky. We don't even see it. We don't even notice it. So, if you were to consider literally every other bit of energy that's out there, none of it gets to us as strongly as the sun. Doesn't mean it's not as strong as the sun. There are balls out there way bigger than the sun, and they give off way more energy. But where does that energy go, and how much energy does it get when it gets to us? It's a pinprick. It's nothing. We don't even see it in some cases because it's so far away. We don't even see that light. That's how the energy is able to dissipate. The question really we want to ask is overcoming energy, but that's a separate issue. And I've already talked about all the different facets of entropy that I'm aware of that I think he would talk about. I was going to pause this and come back after I finish his video and see if I have more to say. And for you it has only been a flash, but I have now seen the rest of his half-hour video, 27-minute video. And of course, he states the rest of the actual what is happening. But he still says that we're radiating out the same amount of energy that we're getting from the sun. That's not accurate. It's just not. There's a lot of energy that goes into the solar rays and whatever else, and it can go into the ocean and turn into basically nothing, as well as the fact that the night side of the planet really isn't radiating anything. Literally, the moment that you have the sun facing us, then that side of the planet has light. The rest of the planet doesn't. So we're only radiating light in one direction, one half of the whole planet, not the entire circumference like he said in the video. Also, just the fact that a lot of wind and whatever else and weather that's happening on Earth, a lot of the heat would be a lot more if our composition was different. So if we want to get more energy from the sun, we need to raise the CO2 levels. That way we end up hotter all over the planet. Contradictory to what we want, because making the planet hotter right now is like burning us too much. That's a problem. So what we want to do instead, technically, to be boring, is to make it so the CO2 levels go down. So how do we do that? Well, we scrub them by making plants. Simply by having more bioplants out there, we're going to have more CO2 scrubbed just automatically. That's why people love planting trees. It is protecting the world. But also you need rainforests that do an extremely large amount of that. And the amount of heat that you have in rainforests is surprisingly high. So it's interesting to know that, like, even though you have superheat in a desert, the same amount of heat, if not more, is in a rainforest, only it's wet. Really freaking wet. And all the oxygen produced there is just extremely dense. Interesting. And like the fact that we can make a chemical that can screw up our ozone layer so much that we end up with holes in it is like, yeah, there's a lot we can do to change how the sun affects the planet. So there's no way that we are giving off as much as what the sun is giving. By the mere fact that we have a dark side, we're giving off half as much. And also, we don't even get all of the energy from the sun that is facing us. There's a lot of it that's just pulled away. But we're getting so much that, of course, the entire planet is able to experience a lot of heat, except for the parts at the poles, usually, sort of, North and South Pole, where, ironically, the amount of speed, or meters per sec, full meters per second, is the most dense. Every time we have a rotation, everything else moves a very large area of the circle. But up at the top, it is a very short area of the circle to move. And I don't know what all that affects everything. But the idea of having a machine that cannot create more energy than it puts out is wrong. It is possible to make more energy than you started off with. But perpetual motion is a thing, and you're just denying it. And you don't even understand how it works. But that's because no one's been able to make a machine that actually utilizes perpetual motion. That's because a lot of their machines, either complicated or simple, are really basic in one way or another. They're missing some parts. They're missing whatever else. And when you think about he mentions a waterfall dam, hydroelectric plant.
Or happen.
So you have to understand that it's weather that makes it so that that dam can constantly have the water be ending up behind it and then constantly flow down to make continuous energy. The continuousness or perpetualness of that energy is evident because we have power from hydroelectric dams all the time. So what if, in order for that to stop, we would have to have the planet stop doing something, or the sun stop doing something, and the weather systems to change. But we can make it, if we can understand that the entire planet is a perpetual motion machine that's working and doing its thing because of the sun, we can apply those same logic and the same ideas with, like I said, the slight differences, in order to make it so that the energy from the sun is increased. Then we have more to work with. So, like, the interesting thing about the whole atmosphere and the energy that is in the electromagnetic field just out there doing its thing, because we have a core that's spinning crazy fast, making energy, because of its own want to move, and the planet and its own wants to move. But what if we started making it so that the electromagnetic field was even stronger, the ball rolling even faster in the opposite direction of the spin of the rotation of the Earth? That amount of friction, that amount of, or however the electromagnetic field is made, what if it could be increased? So many different questions. And the thing is, all of this is, again, a machine. It's an organic machine, but it's a machine nonetheless. So if we can have machines that can use more energy than what we currently do, and be perpetual because we work the sun, then all we have to do is solve for fixing the sun so that it maintains itself and doesn't get destroyed. So all we need to do is then pull the iron out. That doesn't seem hard. Strong enough electromagnetic field, and we can just suck it up like a straw. And then we can deposit all of the lighter energy material into the star so that we can have a constant fusion reinvigoration, and then we can react it and transform it and change it back. Not to mention the fact that we can get energy and turn it directly into matter, making quarks, making our own hydrogen out of what is basically background radiation. Not nothing, but background radiation. The wiggling of the subsurface layer of energy that's just everywhere. Knowing that, it is possible to have perpetual motion. We might not be there yet, but if you then look at, well, we need to actually not just have this star, we need to have the galaxy doing its thing. Well, then we need a solution for how to give energy or give functionality into the galaxy. Since I've already explained that we can make hydrogen out of some energy that we can make, all we need to do is utilize the materials and the momentums of the galaxy itself, and suddenly we are making enough hydrogen to create new stars. And we can feed the black hole so it maintains its strength and maintains its size. So it moves in the same way that it always has been. Or we could even control the momentum of the galaxy itself eventually. So we can have it go off and do whatever it is supposed to do. Trillions and quadrillions of years and quintillions of years into the future, there is something called the Great Attractor that seems to be attracting even galaxies themselves. What we're going to want to do is steer away from that by making the amount of energy flowing through and around our galaxy be diverted somewhere else. The kind of shielding I'm proposing is something we will never end up seeing. But we're going to need it. And then we're going to push ourselves away from that great attractor, not fuse with it. Unless, of course, you want to have a lot more material to work with, then go ahead and fuse with it. If you're adequate with just a galaxy, why would you need more? But then again, why not? Well, the thing is that the fusion of galaxies basically means it's less likely that this planet's going to survive. So we want to get out of that stream. And it's not hard to do, you just gotta divert it a bit. Right? Start using a galaxy engine and we're so far away, we'll never get into that stream. Or we'll be able to stay basically in place and use the stream like a large version of a hydro dam, and all of the stars moving past us, all of the galaxies moving past us, and their momentum added to this basic thing will make all the energy we could ever want. It's going over there. I mean, that'll last for another octillion years or something. We'll be fine. I'm gonna say that I'm sorry for being absolutely pissed off at what you said in the beginning, Derek. Except for the fact that you're still wrong. We're not radiating the same amount of energy as the sun gives us. Not even close. And if you look at Pluto, it's not radiating any amount of the amount of energy it has or whatever else. Or if you look at any of the other planets, like they are using the energy, it's being consumed, it's hardly being pushed out at all. Especially Jupiter. Jupiter is incredibly powerful and strong with its red spot and everything, but it's like it has that specific geometry that makes it happen, and there's no way it can radiate nearly anything at all. But it's close enough to the sun that it should be radiating lots, you would think. There are others that are darker and they radiate even less, but they're just as close. Planets like Mercury and Venus, they have an extreme proximity to the sun. They're getting a certain amount of energy from it, right? Like, is and Mercury just boiling away, turning into nothing? Sort of, yeah. It also has weird weather. I don't know. When I hear something as silly as energy is always equivalent, it never dissipates, and then you talk about a machine that has it dissipate, you're contradicting yourself in the video, and you correct yourself. For everyone who's smart, they either clicked off in the first minute of your video, or they stuck around to see if you have anything worthwhile to listen to. Some people who actually know what they're talking about would, and are not curious at all, would be just like, yeah, he has nothing to say, don't even subscribe to his channel. That's a critique of your video. And as every bit of the video was beautiful and it connects all the parts and it makes sense that even if you have this perfect thing, then it spreads out anyway, and you include all of the rest of the pieces of information. And you did say if, proposing the idea that this is not what the case is, but you said in some ways it is, but it's not. So, Derek, I'm still disappointed in you. Great video, great presentation, some misinformation. Really, really bugs me every time. But, we're not perfect. No one is. And the ability to have the scope of everything and to properly mention it all without any misinformation, or misinformation that is, or tricky information that is meant to eventually then show the truth. Yeah, you do good usually. This one, was hours ago. I just flat out left a comment saying wrong. The first minute was bad theory. And it's true, the first minute of it was bad theory because it poses the question and then it gives you like examples of ideas of the concepts that are actually going to be presented, but then you did the entire proper explanation eventually. But you're still missing the fact that there's more than what you're saying here. And I'll get to that in other videos. I am sorry that I was so yelling, but like, seriously though. It's not okay. Energy does dissipate. It can not just radiate out from the planet in equal measures. It dissipates. It turns into less. The fact that we have a dark side means all the light from the one side and all that heat, and it flows all around the Earth. Most of why we have weather systems, we end up with the change of temperature and stuff. It doesn't all radiate out. It is constantly being eaten. I don't know why you lied.